So good evening. How are you today? It's a nice night out there. I'm Dan Saunders. I'm the chair of the Growth Planning Committee. And on our Growth Planning Committee, we have Barbara Barwise, Paul Hogan, Jim Fitzgerald, Jim McMahon, Mike Scorsese, and Janet Powell. And we are embarking on the update of our comprehensive plan. So if you recall, we went through a couple iterations of the comprehensive plan from '96 through 2005. And the plans didn't pass. So we took over in 2005. A number of us got involved, and we worked through chapter by chapter, if you recall, going to elections and voting on one chapter at a time until 2012, when the entire plan was passed. And thank you very much for passing that. We also sent it to the state, and they approved it as a plan that was consistent with the state planning office. So that brought us some value in that we had a comprehensive plan that land use ordinances are based on. So it gives validity to those land use ordinances. And it also allows us to go after grant money because it's an approved plan. So to stay consistent, we want to update our plan. And we have some new challenges that we face as a coastal community. One is sea level rise. And we also want to talk about sustainability. And so we brought in some consultants. We have Tom Morgan and Liz Durfee, who are going to help us rewrite the plan to work in sustainability throughout the plan and to help us to come up with an ideas on how we may deal with the impact that climate change may have on our community. So as part of that, we have this talk here. God, I'm nervous. I don't know why. You should know. With Dr. Wake. Where is he? He's sitting down right there. So Cameron Wake, he's a research professor at the Institute for the Study of Earth, Ocean, Space, and the Department of Earth Sciences, which is a pretty long title, at the University of New Hampshire. He leads a research program that's investigating regional climate change. And being in the town of Kittery, the coast of Maine is certainly very important to him. He's published over 85 papers that have been peer-reviewed. And in 2010, he received the UNH Faculty Award of Excellence in Public Service. So it's great to be able to have him here to talk to us about the potentials of impact of climate change and sea level rise in our community, to help educate us all. But before we ask him to get up and speak, I'd like to turn the mic over to Tom. Thank you.
Thank you, Dan. Let's see. So the program tonight really has three components. I'm going to speak for a little bit, and Liz will as well, about the comprehensive plan, what exactly it is, why it's important, and we'll also go into a little history of how we came to this place where a comprehensive plan is essential. Then Dr. Wake will tell us about the changing climate, and he'll give us a lot of information about what's up ahead in the next 10, 20, 30 years, and it'll be specific to this part of the Maine coast. And after he's done, we're going to spend a few minutes trying to figure out how we integrate all this climate science into the new comprehensive plan. And I think the two really, it's really important to have a comprehensive plan that recognizes what's really coming up ahead, because we haven't been here before. So this is going to be kind of innovative, and Liz and I are pretty excited about it. But in order to get going on what a comprehensive plan is, I thought we'd start with a little history here, how we came to have land use regulations and planning in the state of Maine. Starts, well, it really starts back in England, but we'll start in 1788 here with the Constitution. And the 10th Amendment of the Constitution said that all those powers of the federal government that are not specifically enumerated in the Constitution are delegated to the states and to the people. And in many cases, most states delegated many of their powers to the municipalities. And that, when we're talking about powers, we're talking about police powers. And back 200 years ago, the police powers were focused on health, safety, morals, and the general welfare. This is one of my favorite pictures. I live in Portsmouth most of my life. This is Portsmouth 1907. Those of you who are familiar with the city, it's Market Square, where you can see Benjamin Green's Apothecary. That's Starbucks, to give you a little reference where you're looking at here. So that's changed. And I love the picture of the police officers walking across the square. They weren't on horseback or in cruisers or anything. This is how they policed the city back then. But I want to bring your attention to Mr. Wendell's hardware store. In 1907, you recall, that's when some of the more well-to-do residents started to purchase motor vehicles. They were a pretty novel item at the time, and not too many people could afford them, and they quickly figured out they didn't work too well unless you had a steady supply of fuel. And there were no gas stations, but Mr. Wendell recognized the emerging market, so you can see that if you look closely. That's why I brought this here. The sign just went up. It hadn't been up very long. It's kind of temporary, but he's trying to market gasoline out of his hardware store. Now, he was also selling ammunition and kerosene and dry goods. And he thought it was a great deal, to just, had another product he could sell and make some more money. But Portsmouth was a little nervous by then because at this Market Square, it had already seen 3 major fires that destroyed much of the city. And it got him to thinking that, maybe if you have the power, the city has the power to pass ordinances for safety and general welfare, it might be a good idea to rethink Mr. Wendell's hardware store and maybe put the dry goods over here and have the gasoline way over there, in a different building, a different part of the city. And that's where that type of thinking. Of course, the setbacks too are a good idea if you're selling gasoline as well. New York City had a different problem. The technology enabled them to build buildings much higher than they had been before. It was the steel frame skeleton that was invented in Chicago in the 1880s that enabled that. And the Equitable Life Insurance Company, they bought a full city block in Lower Manhattan and decided to make their headquarters 40 stories tall. But what they did, what hadn't been done before, is they covered the entire block. And they built as high as they could. And those smaller skyscrapers nearby suddenly found that they were in the shade all the time. That the sun didn't shine on their property anymore, and they were unhappy about that. And that prompted enough political pressure to force the city of New York to adopt the first zoning ordinance in the United States. Now, further up the coast, I don't know how many people you recognize, this is Kennebunkport. And this is the arrival of a new group in town. These are the summer people. And this is from the 1890s. And they had money and they had leisure time. And in the 1890s, Kennebunkport was all about canoeing. And the one thing I like to point out, just to notice that everything in this photograph is made of wood. We'll get to that in a few minutes, but just take note of that. And this is the same crowd. It's a different picture. Actually, when they were just getting on the boat, they were. I got kind of. I wonder what would happen if the canoe flipped over with all that clothing. It'd be, it was. They were not something I would let my family do. Now. Euclid, Ohio is a little suburb of Cleveland, and early in the 20th century, the folks who lived in this village were anxious. They saw a big, heavy industry in Cleveland expanding outward in their direction, and they were afraid that the industry was going to come into their village, and that would make their quality of life diminished. So they passed a early zoning ordinance, and they did a few things that ordinance. One thing is they said, residential over here and industrial over there, and you're not going to let any industry over in the residential part. They were all about protecting their peace and quiet and their tranquility there. But of course, there was an industrial entrepreneur who disagreed with them. He wanted to build a big factory in their residential area. It went to court, ended up in the Supreme Court, And the village of Euclid, Ohio prevailed. And that was a landmark case. It was the first time the Supreme Court, even though New York City had had an ordinance for 10 years, this is the first time it made it to the Supreme Court. And the Supreme Court said, yes, zoning is consistent with the United States Constitution. And one of my favorite quotes from that decision was from Justice Sutherland, pointing out, there's nothing wrong with pigs, but you don't want them in the parlor. They belong in the barnyard. And that's the whole part, concept behind separating the uses. The use itself isn't bad, but sometimes you put it in the wrong place. That's a problem. Now, back to Maine again. There's a fellow named Libby down in York Harbor. His business was commercial campgrounds. He established it in 1923. And unfortunately for him, in 1925, the York Harbor Village Corporation decided to pass a zoning ordinance, and they wanted to make sure that the large houses that had been built along the shore didn't have any people in tents, right in the immediate vicinity. They saw that as incompatible, much as the people in Euclid saw industry as a threat. So they divide their zoning map into two, Zone A and Zone B, and they told Mr. Libby he can't have a campground in Zone B, and he persisted, so they went to court. And in 1928, the court ruled in favor of the York Harbor Village Corporation, and it was the first time in Maine that the Maine Supreme Judicial Court had said, yes, zoning is consistent and lawful, consistent with the Maine Constitution. And Libby's is still around, they're just not in the same location. Now, the Fifth Amendment was talking about taking people's property rights. They started off with a theory of bundle of rights where under the U.S. Constitution, you can do pretty much anything you want, but then it kind of starts getting constrained pretty quickly. And the Fifth Amendment allowed the government to come in and take away some of those rights for a larger public purpose. And these are some of the public purposes that they were allowed to take property rights from. And this goes back to the picture from the 1890s. I guess I'm jumping around here, but just flashback real quick to the people with the canoes. They were coming from the city, and they had certain preferences. One of them was for running water, other was for having a fire brigade nearby because everything was made of wood. And the other one, of course, as we saw in York, is they wanted to use this new concept of zoning to protect their investments. Now, the people in the other parts of these coastal towns, they didn't see any advantage to them. They didn't want to pay taxes for fire brigades that weren't going to make it to their house in enough time anyways. So the legislature kind of compromised, and they let the people in these little village corporations adopt land use regulations and support fire brigades, and with the rest of the taxpayers further out did not have to pay for it. So back to public purposes here. So those are some of the purposes that the government can take your property rights for. Now notice at the bottom what else the court said, and this is very important. It says if you want to have a zoning ordinance, you have to have a plan to back it up, a plan that supports it, a plan that's consistent. And the reason being is that constitutional provision, that the Supreme Court said it was okay to have zoning so long as for a rational purpose. There's a plan to support it. It can't be arbitrary. And that gets us back to the comprehensive plan we're talking about, we're engaged in updating right now. That's why it's important, because if your plan doesn't pass muster or if it doesn't make sense, then your zoning ordinances will be vulnerable to a legal challenge. In fact, this legislature kind of made it plain by saying if your plan is 10 years old, your zoning ordinance is not supported. Justice William O. Douglas, he took a stab at broadening the definition of public welfare back in the 1950s, and he kind of opened the door to let government step in and protect historic properties, but also open spaces. And this open space I particularly like here in town, in that that. And with that, I am going to pass the microphone over to my colleague, Liz Durfee.
All right, hi everyone. So I'm just going to go over a couple slides about the comprehensive plan to get you prepared for Dr. Wake's presentation. So the town's current comprehensive plan was prepared and adopted on a chapter-by-chapter basis in 2012. And it contains a number of policies and implementation strategies that we'll be working with the Growth Planning Committee to review, revise, update, add new strategies throughout the process of updating this comprehensive plan. I'm going to take a quick step back for those of you who haven't thought a lot about comprehensive plans in a while, and just go over a couple basics. So what is a comprehensive plan? This is a planning document. It's a long-term plan, typically a 10-year plan, and it contains a few key elements at a bare minimum, and these include an inventory and analysis of trends, data across a multitude of planning sectors, policy development, an implementation strategy with a timeline, and a regional coordination program. The plan's intended to help guide the town to identify areas that are more appropriate for growth based on existing infrastructure, future planned infrastructure, your open space, your valuable natural resources, and areas that are vulnerable. Why is Kennebunkport preparing a comprehensive plan now? It's time for an update. It's a great opportunity to reassess and articulate the community's vision and really take a holistic look at the town. We're going to be looking at housing, we're going to be looking at population, your natural resources, water resources, and putting all that information together to help identify which areas are best for growth and development, which areas should growth and development be steered away from, and how to address a multitude of challenges for the future. And also it's important to update the plan to meet state planning requirements, as Tom alluded to. This is a screenshot of a page from Chapter 208, which is the state's criteria and procedures for comprehensive plans. So this is a guidance that we'll be following to ensure that your plan meets the requirements of the Growth Management Act. And why conform with the Maine Growth Management Act? We touched on this a little briefly already tonight. It's important and it's necessary to legally impose and to enforce zoning. The state directs its investments related to growth in areas that are targeted for growth in municipalities that have an approved plan. You also have the opportunity to get some preference for some state grants and funding based on having an approved plan. And the bottom line that we believe is it's really good to ensure good planning. These two maps on the screen show on the left the Kennebunkport rate of growth areas, and this was an output of the current comprehensive plan. And the lighter yellowish color in the south area of town shows areas targeted for growth. The middle zone is called a transition area, and it's colored in yellow. And then the areas, the rural growth areas, are in green on the top of the screen. This map identifies, it guides how many permits for dwelling units are allowed in those different areas of town. So it's an important tool for your residential growth. And then on the right-hand side of the screen is the zoning map, and I know the colors are a little bit light on the screen here, but it shows all of the different zoning districts. There's 12 within the town of Kennebunkport. Each of these zoning districts has a set of permitted uses and dimensional standards, and these really shape development, the types of development that's allowed, and the character of those different districts. The reason that we're showing these together is that you can see that the boundaries don't exactly align. And this is something that we'll be looking at with the Growth Planning Committee throughout the process of updating the plan, is to assess whether or not these growth areas are aligned accordingly with zoning districts, whether or not it's possible that zoning district boundaries need to change in the future, and double check to make sure that the zoning ordinance is really implementing the plan on the left, which is really what's driving the vision that came out of the current comprehensive plan. This spreadsheet shows a few of the different zoning districts. They're lined up in the column on the left, and the dimensional standards of those zoning districts. And we pulled this information from your land use ordinance, and then the column all the way on the right shows the growth area, and that corresponds with the map on the left in this previous slide. So you'll see the zoning districts shown here are some that are targeted for growth or have a higher growth rate permitted. The dimensional standards are one of the tools that a community has for encouraging growth or density in different areas of the town. A smaller lot size, for example, smaller minimum lot size requirement can make development more feasible in certain areas of town. At the same time, having a larger minimum lot size doesn't necessarily help you preserve rural character because it can result in sprawling development patterns. So we'll be looking at this zoning table throughout the process of updating the plan and seeing if it aligns with the community's vision. The second column from the left shows minimum lot area, and if you can't read the numbers from there, the minimum lot area ranges from about 20,000 square feet, which is roughly half an acre, to 40,000 square feet. So they're relatively large lots for a downtown setting. We're also going to take a look at the Buildout Map. This is a clip from the Buildout Map that was developed during the current comprehensive plan process, and take a look at some of the new challenges and priorities, including housing, housing demand and housing types, and also climate change impacts, and what areas are more vulnerable to the impacts of climate change. Lastly, I just wanted to highlight a couple of the timely topics that we're going to be covering. This isn't everything we'll be covering, but we'll be touching on tourism, traffic congestion, housing affordability, population, demographics, short-term rentals, the village parcel, preserving the fishing industry, climate change, and a number of zoning issues. These are all things that the Growth Planning Committee has expressed interest in. Before I turn it over to Dr. Wake, I just want to highlight our project timeline. This is up on our website. We'll put our website up later in the presentation. We're right now where the yellow arrow is pointing. We'll be working on this project for roughly a year. We're hoping to wrap up the drafts at the end of December of 2020 to get them ready for adoption in 2021. So with that, I will turn it over to Dr. Wake.
Thank you, Liz. Tom, or Liz, would you be so kind? All right, well, thank you for inviting me up to talk about climate change. I'm going to talk up here, because I'm a walker. I'm going to point at the screen off and on. We've got about an hour from now, so I'll try to talk for about 45 minutes and then answer your burning questions at the end of that. I'd like to start by saying I think I'm just really impressed with the town of Kennebunkport for taking this step at this point in time. There's a lot of various strategies that are isolated and by themselves to try and address climate change, and I think doing it within the framework of a comprehensive plan is really the most sane approach to dealing with what is a really big challenge. And the challenge in your comprehensive plan is going to be that you've never really had to deal with the issue of climate change like you are now, because we know so much more about it, and hopefully you'll know a little bit more about it by the time we're done tonight. All right, so if you want to follow me, and you're all on Twitter, I know you can, that's my handle, the Climate Doctor. So if there's, go ahead. So if there's nothing else that you remember from tonight, I really want you to remember these 12 words. 30 years of climate research distilled down into its essence, right? Climate change is real. It's caused by us. Scientists agree it's bad, but especially with good comprehensive planning, we can fix it. All right, I want to start by saying I think climate change is the most significant grand challenge that society faces today, not only in Maine or the United States, but around the world. So I'm just going to provide you some framework for that. So you might think that childhood hunger and food insecurity is the most significant challenge. Right now, 1 in 5 children in our country is food insecure, and the ratio is much higher in other countries around the world. So that's going to be made more difficult or impossible to address because our tropics are going to be heating up so that it's going to be really hard for people to work outside. It's going to be so hot, it's going to be really difficult to grow crops. We're also going to see an increase in big extreme precipitation events as well as big droughts, making it harder to bring those crops in. So in the area of the world where the majority of people live, it's going to be much harder to grow food, which means it's going to be much harder to actually address issues of childhood hunger. You might think that national security is the most important grand challenge facing our nation. The Pentagon puts out these quadrennial defense reviews, usually every 4 years, and in an 80-page document, there's 9 or 10 pages dedicated to the issue of how climate change is a threat multiplier that drives conflict. The threat multiplier part is that climate change drives environmental degradation and social tensions and political instability, which, if it doesn't by itself lead to conflict, actually enhances conflict. You might think that preserving biodiversity is the most important grand challenge. We're actually already in the 6th great extinction that the Earth has experienced. So there have been 5 great extinctions before. Humans are now driving the 6th great extinction, initially as a result of land use change, cutting down forests to grow crops, but now more and more being driven by climate change. Or you might think that the most important grand challenge we face is public health. It's going to be made more difficult or impossible to address because warmer temperatures are going to result in premature death or sort of extreme, so warm temperatures that lead to heat waves are going to drive an increase in deaths. But we're also going to see an increase in the spread of vector-borne disease. What's your favorite vector-borne disease here in Kennebunkport? Ticks, right? The tick is the vector for the disease, but we're going to see an expansion of, mosquitoes, like mosquito-borne diseases like malaria and dengue fever. Also, warmer temperatures lead to more rapid chemical reactions that drive an increase in air pollution. So dealing with public health is going to be much harder in a world warmed by greenhouse gases. So with that said, 3 things that I say in almost every time that I talk about climate change. The first is that climate changes. It always has and always will. The only difference is that today we have an extensive and ever-growing body of evidence that indicates humans are the main driver of that change. Once you understand that, once you fully understand that statement, the following is true as well. The future climate is literally in our hands. The climate that our children and grandchildren and great-grandchildren and generations after that inherit depend upon the decisions we make about how we produce and how we use energy. We are now in charge of our climate globally. The second is I just totally reject this notion that it's the economy versus the environment. It's the economy and the environment. We have to deal with both at the same time, and especially in New England, so much of our employment actually derives from the clean environment that we have and the clean water, et cetera, and cleaning it up. Third is, after dealing with this issue for over 30 years, I find it to be a distinctly moral issue for many reasons. But the 2 that I state most frequently is, one is it's those who are most vulnerable are going to suffer the most. Just look at any of the big weather disasters that we have, whether it's Katrina or Sandy or anything else. If you're young or old, if you're infirmed or if you're poor, you are much more likely to suffer. Most of us across, I would argue, New England are going to be all right. We're going to figure out how to adapt to climate change. But it's those who are most vulnerable are going to suffer the most. The other part to that is when we drove up tonight, we carpooled. We're good carpoolers. But we emitted a bunch of carbon dioxide to the atmosphere that's going to be there for well over 100 years, which means it's going to be warming the climate for a long time. We get all the short-term benefit of that, but we put the impact off on future generations, which is also really morally reprehensible. So it's a moral issue. We actually have to figure this out, I would argue. I am by training an ice core paleoclimatologist and geochemist, say that like 10 times really quickly. I'm not going to talk a lot about ice core data, but I want to put the current context in which we find ourselves in the Earth's climate history into a little bit of perspective. And I'm going to use that using an ice core record from Antarctica from 2 different locations, one called Vostok and one called Dome C, and we've spliced this record together. So why Antarctica? Because it doesn't snow much in Antarctica and the ice is really thick. So when we drill down, we can go far back in time. Glaciers are these beautiful, if you go to places where they're nice and flat, you essentially go back in time as you drill down. So this is a record that comes up to the present, but it goes back over 800,000 years. So I'm showing you 800,000 years of Earth's climate history. In the blue, I'm showing you carbon dioxide concentrations of the Earth's atmosphere. And we get that by actually pulling these ice cores out, and there's bubbles that are trapped in between the ice crystals. We crush that ice core, extract the air, and we can measure the trace gases in that air. I mean, that's, first of all, that is totally cool. Right? We know what the carbon dioxide content of the atmosphere was 800,000 years ago. This is ice core scientist's gift to the rest of you. And so you can see we have this, I want to say, why do we care about carbon dioxide? It's a greenhouse gas. I'm not going to go into the physics of greenhouse gases. All you need to know is that a greenhouse gas is the same thing as a blanket you put on your bed on a cold winter night. You put the blanket on, you get warmer, you increase carbon dioxide content in the atmosphere, the Earth gets warmer because it's trapping the long-wave radiation coming from the Earth, just like the blanket traps the long-wave radiation coming from your body. It's really that simple. So here we've got carbon dioxide, and then we also measure temperature by looking at stable isotopes in the ice, which we then melt and analyze in a mass spectrometer. So hopefully you've looked at this long enough to see that there's this fundamental correlation between high carbon dioxide and high temperatures, low carbon dioxide and low temperatures. All good? We're good on that? See that relationship? The other thing is you'll see that this varies a lot going back in time. We've actually been through 8 cycles of this. Right here, 18,000 years ago, when temperature was low and carbon dioxide was low, that was the last glacial maximum. There was nothing around in New England except ice, right? No trees, no forests, no lakes, no mosquitoes, no nothing. Yeah? So those are, this is a measure of Antarctic temperature, but this is the stable isotope of hydrogen to deuterium. And so the range here is about, so it's a fantastic question, and I could spend hours talking about it, but I want to tell you, it's about 6 to 7 degrees centigrade Celsius shift. Although some of my glaciologist colleagues would say it's a lot more than that. So it's at least 6 to 7 degrees Fahrenheit. Excellent question. I should have put temperature on there instead. Sorry, Celsius. So you'll see that there's these 8 cycles, so they're linked, and there's these 8 cycles going back in time. So each one of these packets we call a glacial interglacial cycle. This is a glacial age. Last 10,000 years is interglacial. So 1, 2, 3, 4, 5, 6, 7, 8, right? These happen about every 100,000 years. And those cycles are being driven by the change in the amount of solar radiation that comes into the northern hemisphere. That's a result of change in the Earth's orbit around the sun, change in the tilt of the Earth's axis, and a wobble in the Earth's axis. Those 3 different cycles line up to drive 100,000-year cycle. So climate's changed. It always has and always will. In this case, primarily because of the amount of radiation that we get from the sun. Next, so I've taken those, I've changed my y-axis, right, the same two records. And now what I'm plotting is how carbon dioxide has changed in the atmosphere just over the course of the last 50 years since we started measuring it in 1958 at Mauna Loa as part of the International Geophysical Year. So when we started measuring it, not we, Charles Keeling, it was at about 310 parts per million by volume, and now we're up around 415 parts per million by volume. The amount that the carbon dioxide has increased in the atmosphere since 1958 is equivalent to a shift that we see between a glacial age and an interglacial age. We've already dramatically changed the Earth's climate system. If we continue to rely upon fossil fuels as our main source of energy, somewhere around 2100 we'll end up at 1,000, 1,200, 900 something parts per million by volume, carbon dioxide in the atmosphere. That will result in catastrophic climate change. Conversely, if we invest in energy efficiency and renewable technologies, we might be able to stabilize somewhere around 450, 500. If you're really optimistic, we might be able to get back to 350 parts per million in a couple hundred years. But this is where we're going, and this is where we need to be. All right, so that's the only set of slides I'm going to show you that's 800,000 years. Sure. So 800,000 years, we're not talking millions a year. Yeah, so essentially when it's really cold, the ocean absorbs a lot more carbon dioxide. When the ocean's warm, it releases carbon dioxide. So changes in the Earth's orbits change the amount of snow that remains in the northern hemisphere, changes the reflectivity of the surface. You start to cool the planet. The ocean sucks more carbon dioxide. There's more carbon dioxide that comes out of the atmosphere. It cools the planet more. Right? And then, sorry, wrong way. Did I do that wrong? I got it. Yeah. So it's a positive feedback loop. Once you start to cool something, it's going to get cooler because you're taking carbon dioxide out of the atmosphere. And once it gets warmer, it's going to be a positive feedback loop. So about half of the warming is due to changes in greenhouse gases, and about half the warming is due to reflectivity changes on the surface. All right, so coming back up to the present, we're now from 2018 going back to 1880. This is atmospheric temperatures, and I just want to show you that, right? Something happened in 1970. We're on this long-term warming trend. 16 of the 18 warmest years have occurred since 2000. Don't let anybody tell you that the Earth warming has stopped, right? It has continued. It goes in cycles. There's reasons for that, but there's this long-term increase. A little more shocking than that is that the atmosphere really only contains about 10% of the increase in energy as a result of the increase in greenhouse gases. 90% of the energy is now stored in the ocean. So what you're seeing here is the heat content. It doesn't change the temperature so much because the ocean is so huge. It's got a much bigger thermal mass. But the amount of energy stored in the ocean has increased substantially. So you'll see that the red lines represent different oceans of the world, the different red lines, the surface to 2,300 feet, and then 2,300 feet to 6,560 feet. The amount of energy stored in the ocean is huge. So you can also thank your ocean for actually absorbing a lot of the energy, because if it wasn't there, the atmosphere would be a lot hotter. All right, just a couple of other global records before we dive into what's happening in New England and Maine. This is a really important record. We first start tracking the extent of Arctic sea ice in 1979 when we put polar orbiting satellites up. And what I have plotted here is the end of September, or so the month of September sea ice extent, which is the smallest extent of Arctic sea ice. It's when it's the warmest in the Arctic. It sort of takes a while for it to warm up. You'll see back here we had sort of somewhere between 7 and 8 million square kilometers in 1979, and now we're down to about 4.5. Right? On average, we've lost 11% of the area of Arctic sea ice every decade since 1979. Why do you care? Arctic sea ice is white, and it reflects solar radiation back out into space. When you remove that Arctic sea ice, you get ocean water that's dark, and it's also opaque, so the sun comes in and it heats up the surface of the ocean, the upper 5 to 10 meters, and it retains that heat. So you lose Arctic sea ice, you lose the air conditioner for the northern hemisphere, and the best estimates now are that this Arctic sea ice will completely disappear in a decade or two, and we're not going to get it back because the ocean is going to be warming. Not only are we reducing the extent of Arctic sea ice, but we're also reducing the age of Arctic sea ice. This is a little bit hard to see, but down here, what you have is the age of sea ice in years, with the dark, dark blue as 1 year and the white as 9 years old. So 9-year-old sea ice is going to be 40 to 50 feet thick. Really, really thick. 1-year-old sea ice might be 10 feet thick, so a little bit higher than this room. So you see up here, late March in 1990, right, you've got lots of sea ice that is older than 5, 6, 7, 8, 9 years. It's very thick. It's resilient to a particularly warm summer. Come back to late March 2016, right? There's much less and almost no really old sea ice. It's all very young sea ice, which means it's thin, which means it's really vulnerable to warm Arctic summers. All right, so we're going to move from sea ice to land ice. I'm going to talk about Greenland and Antarctica. Here's a nice picture of Greenland over there. This is a graph that goes from 2002 to 2016 that shows the mass balance of the Greenland ice sheet. So how much mass it gains in the wintertime when the snow falls and stays there, and the mass that it loses in summertime when it melts or when big ice flows calve off of the glaciers that drain the ice sheet. So you can see long term, we're losing considerable amount of mass on the Greenland ice sheet, and most of that mass is being driven where these really big glaciers drain the Greenland ice sheet. This one is a pretty famous glacier called Jakobshavn. Probably still is one of the fastest flowing glaciers in the world, but it's draining this huge watershed, essentially, or ice shed of Greenland. So on average, Greenland is losing 281 gigatons of ice per year. So what does that mean? What's a gigaton of ice? It's a lot of ice. So a gigaton, it's 1 billion tons of ice, right? How much is 1 gigaton, 1 billion tons of ice? So 400,000 Olympic-sized swimming pools. So how do you even figure that out? I mean, can you picture that? So a better analogy that I came across was if you put a piece of ice down in Washington, D.C. that went from the Capitol building to the Lincoln Memorial, the entire width of the wall, 3 times higher than the Washington Monument, that would be 1 gigaton of ice. So we're losing 200, on average, 280 of those per year. It's the equivalent of rising sea level about 2/3 of a millimeter per year. So we're also losing ice from Antarctica at about half the rate of Greenland, 125 gigatons per year, so that's about 1/3 of a millimeter. And most of it's coming from West Antarctica, also from those really big glaciers that drain the part of the West Antarctic ice sheet, so this part of the ice sheet. The challenge with Antarctica is there's a lot more ice to lose, and it looks like the rate at which ice is being lost is speeding up much more quickly in Antarctica. So all of the uncertainty that we have in sea level rise out by 2100 is actually driven by the ice dynamics that we don't fully understand for Antarctica, that we're doing a lot of work to try and figure out. And then that is contributing to sea level rise, both the warming and the ice melt. The sea ice doesn't contribute to sea level rise because it's already in the water. So this is a long-term record of sea level as measured by from a series of different satellites that were designed to measure the height of seawater. The red line represents the increase in sea level rise as a result of increase in the temperature of water, which means it's going to, as it gets warmer, it gets less dense, so it takes up more volume. And then the blue line represents the transfer of water in the form of ice from the land into the ocean. So that's the global mean ocean mass. And you can begin to see that this is beginning to hit an exponential curve. So exactly how fast this increases is going to dictate how fast our seas rise. And then here's the main driver of it all. So I started off talking about carbon dioxide from an ice core. Here's the Mauna Loa record of carbon dioxide right up through 2019. And you can see we're now up 415 parts per million by volume. Where's all that carbon dioxide? What's the breakdown of greenhouse gases? I talk primarily about carbon dioxide. It's not the only greenhouse gas. There's carbon dioxide that comes from fossil fuels. There's carbon dioxide that comes from land use changes, primarily when we cut down trees and burn them, but also how we actually use our soils. There's carbon dioxide associated with chemical processes. Methane, a lot of methane comes from anaerobic processes, so anytime we grow crops that are underwater, also sort of, right, we all know that cows now actually burp a lot of methane. It's a real challenge. Nitrous oxide primarily coming from our agricultural systems, and then CFCs, man-made greenhouse gases. So CO2 from fossil fuels is the biggest one, but you can't solve the problem just by looking at that. You have to actually look at the rest of the greenhouse gases as well. And here's just how they're broken down by sources, right? You can see electricity and transportation close to 50%, industry about 25%, right? Food and land use about 25%, then some other small stuff. But again, you can't just work on the electricity part of the problem, or just on the food part, or just on the industry part, or just on the transportation part. We have to deal with all of these at the same time. I'm going to skip that slide. I'm going to skip that one too. All right, so I want to transition into what's happening in Maine. I should add that you're going to have access to the PowerPoint, and on all the slides I have various sources, and then at the end I have a particular set of sources that I think are really valuable for you in Maine. So for example, a lot of the figures I'm going to show you now come from Maine's Climate Future, which was a report written by scientists from the University of Maine. It's a really good document. I wrote a similar document for New Hampshire, but we're not in New Hampshire, right? We're in Maine. I just want to show you long-term Maine's annual average temperature. It is in fact getting warmer, right? It's increased a lot since 1895. But if you look at this closely, the rate of increase has actually is much steeper since 1970, right? So we're heating up much more quickly over the past 50 years. There's a really interesting atmospheric circulation changes that are related to sea surface temperatures in the Atlantic. It's called the Atlantic Meridional Oscillation. And we have sort of warm phases and cold phases depending on exactly how warm or cold the bodies of water in the North Atlantic are. So temperature degree, this is sea surface temperature, right? We have warm phases and cool phases. So that's actually reflected in Maine's temperature. So you might call this natural oscillations, but you'll see that the warmer events are getting warmer and the cooler events are getting warmer. So this is my, my reference to we have to learn how to be able to walk and chew gum at the same time. Climate does not just change for one reason, right? Does it change naturally? Yes. Does it change because of human beings? Yes. We have to put those two together so you get cycles, but you get trends over time. So the overall trend is to warming, even though we have to deal with the cyclicity. We've also seen an increase in precipitation. You can see lots of variability. You might even say you think that variability might be getting bigger. That's a pretty big challenge to actually prove statistically, but we are seeing an increase in precipitation. And I would argue that's really good because Maine and New England has a lot of fresh water, and we're going to continue to have a lot of fresh water because of rain. There's other parts in the USA that are facing significant drought, and I would argue they might be looking to New England to say, wow, they have water up there that maybe we should go up there because I've been really thirsty living in Tucson or somewhere else. So I think this is this is going to present some challenges as well I'll get into, but this is something we need to begin thinking about is how we preserve what is a really precious resource. So the challenge is that more of that rain is coming in fewer events. This is actually from a NOAA state climate summary, so this comes right from the most recent National Climate Assessment. And what you're looking at is change in the magnitude of the 24-hour, 100-year precipitation event, which is the design event for a lot of the flooding. It helps define what the 100-year floodplains are, for example. And you'll see, right, coastal Maine is right in the spotlight of having an increase in that amount on the order of 20 to 30%. Let me show you what that actually means on the ground. Oops, go one more. No, go forward one more. There we go. So that's the one I wanted. So So there's these updated extreme rainfall climatology. So if any of you were engineers designing 20 years ago and you tried to get a site plan permit for somewhere that was near a floodplain, you would have gone to this document called Technical Paper 40 that was published in 1961 that told you that that 24-year, 100-year rainfall was 6.3 inches in coastal New Hampshire and coastal southern Maine. So that analysis has now been redone by different entities. One group that's done this is the NOAA Northeast Regional Climate Center. They have this wonderful website called, we could just call it precip.net because it'll get you to the right place. And this is what the new 100-year, 24-hour rainfall event is. And you'll see down here, southern Maine is in the bullseye, right, of 8.5 inches. So we've seen an increase of 6.3 to 8.5, which is right around that 25 to 30%. But that's a big deal. Right? So this leads to substantially more flooding. And then the NOAA Atlas just came out recently. It's hard to see this. There's a circle of 8.5 around Portsmouth, and then they put us in the 8 to 8.5 range. Similar, different sort of type of statistical analysis with a similar result. So the point here is that we're seeing our bigger precipitation events have gotten much bigger. Right? So we're getting more rain. But more of that rain is coming in really big precipitation events, which makes it difficult because that drives flooding because so much of the areas where we built in are close to water. Actually, can you go back one? Yeah, and so this is an analysis that we just did for the Great Bay watershed, and I haven't done this for this area yet, but we're looking just at the extent of 4-inch precipitation events over 2 days or more, and we did that for 5 long rainfall series, the 5 longest rainfall series we could get. So Durham, Lawrence, Concord, Sanford, not far from here, and Epping. And what you see across all of these is this increase in the number of extreme precipitation events, right? Now we're talking not 20 or 30%. Like Durham has gone from, even if you take this one, right, 2 to 3 on average to 6 to 7 on average, a 2 to 3-fold increase, and it's across all of these stations. Right? And when you're getting more than 4 inches of precipitation, those are the big events that are leading to flooding. All right. And not only that, if you're living in Maine and you've been paying attention, you know that we have this really unique signature of sea surface temperature warming is the Gulf of Maine is warming faster than 99% of the rest of the ocean. This signal has become crystal clear. It's really been developed by Andy Pershing at the Gulf of Maine Research Institute, but it's really a problem. This is a snapshot of one of the second hottest day that's ever been experienced in sea surface temperatures in the Gulf of Maine. These are anomalies, so they subtract out the long-term average. So you can see the Gulf of Maine here, right? These deep reds. This is on 8th of August, 2018, is 5 degrees centigrade warmer than average. That's a huge deal for an ocean ecosystem, and it's going to be really big for our lobster industry. And I was just up at the Gulf of Maine 2050 conference 2 weeks ago, and I heard that the lobster catch this year in Maine is down 40%. And so is that a 1-year problem, or is that the beginning of the end of our lobsters? So it's hard to say, but ultimately that warming is really going to have a significant impact on what is by far the most important commercial fishery to Maine, and it's already decimated cod stocks. So this is a really big challenge and something that we need to begin thinking about in our comprehensive planning. Not only that, all that carbon dioxide in the atmosphere is also dissolving in the ocean. And when you dissolve that carbon dioxide, you actually make the ocean water more acidic. So this is a graph from a paper written by Joe Salisbury and his colleague where he's modeled pH acidity in the Gulf of Maine, and we've seen this significant downturn trend over time. There's only a few measurements, so he's taken those measurements and developed this pretty sophisticated model, but we're seeing this significant ocean acidification. It's really a complicated problem because it also depends on sort of how much calcium carbonate there is and how much detritus there is coming in from the land and what the temperature of the water is. But this is a really big concern, especially for shellfish, because when the ocean gets more acidic, it's much harder for them to make their shells. All right, everybody take a deep breath. We're all going to be okay. We all have resources. All right, so that's sort of globally what's happened in the past and then what's happened in Maine. And now I want to talk about what might happen in the future. And our future climate, as I started out saying, literally depends on what we do in terms of how we produce and how we use energy. So because it's based on what human beings do, it's impossible to predict. So what scientists have done to deal with this is that instead of providing a single prediction, like you see on the news, like they predict the weather, so they do that because they have the short-term models. It doesn't really depend on what humans do. They have short-term models that predict the weather. They can associate probabilities with it. That's not how we project climate in the future. It's completely different. So what scientists have done is developed scenarios of how much carbon dioxide human activities might put into the atmosphere. And then we take those scenarios and we use it to drive global climate models, which are sort of the only tool we have to assess how climate might change in the future. If we had another planet Earth, we could do the experiment there. We don't have that. We're doing the experiment on this planet. So these are the scenarios that we have come up with. So these are global carbon emissions, right? This is historically what our global carbon emissions have been for the last 100 years, and here's what they might be for the next 100 years. And I'm going to share with you 3 scenarios. There's a potential for a low emissions scenario. This would mean a really dramatic and rapid decarbonization of our entire economy around the globe. I would argue that this is really not going to happen in the current way that the world is run. If we did that, we would see that global temperatures would really go up only another degree or 2 Fahrenheit. Right? So this is what the Paris Agreement was about trying to get on this pathway, but that's really, really difficult and really challenging. A second scenario, we're going to call that the lower scenario, is one where we continue to emit greenhouse gas to the atmosphere to the middle of the century. Actually, what happens is the developing world doesn't. The developing world dramatically reduces its greenhouse gas emissions. The developing world, Africa, China, India, continue to emit to the middle of the century, but then they turn their economies around, so we significantly reduce greenhouse gas emissions. That sort of limits the warming to, right, somewhere around 4 degrees Fahrenheit. So I would say if we work really hard together, this is the pathway that we could be on. Next one. If we decide we're not going to do anything and we just continue to burn fossil fuel as our main source of energy, right? We see this significant increase in emissions going out towards the end of the century, and we have unmitigated warming to 7, 8, 9, 10 degrees Fahrenheit. So that's this curve here. So let me ask you, what greenhouse gas scenario do you think we are on right now? You got the low, you got the Paris, the low, or the high? All right, so we're all in agreement. Next slide, so when you look at these, this is the high, right? There's the low, there's the medium. That black line represents the curve that we're on. So that's the change that we have to drive, is we have to bend this curve from being on the high emissions scenario, and we have to bring it down so we're on the lower scenario. And it would be nice to get down here, but I find that highly unlikely. All right, so then we take those greenhouse gas emission scenarios, we put them into global climate models, we get the outputs in these big grid cells, and then we actually statistically downscale those again to get a better sense of what's going to happen across New England or in particular communities. So here's what we've done for the Northeast. The RCP 4.5, when you see that, just think lower scenario, and RCP 8.5, just think of that as the higher scenario. What you see this sort of bad hair day diagram in the back. That's the 29 different climate models that we've run. And then the bold line represents the ensemble mean, which is really the best projection that we have. So down here, the dark black line here represents what our actual temperature was across the Northeast. And the gray line represents how we modeled that. So we're reducing the extremes, but we're capturing the middle, right? And that's when you average over 29 models, you expect that to happen. So as we go out in the future, there's 2 things I want to show you very clearly. By 2040 to 2050, there's no difference between a low emissions and a high emissions scenario. You all see that? It's really important. That is the amount of warming that we have already committed to. We're not going to get away unless there's a miracle in the way that we produce and use energy. We're not going to get away from that warming. So we're looking at something on the order of, right, another 2 degrees centigrade, right? 4 degrees Fahrenheit warming. That's just something that we are going to have to adapt to. Whether or not we're on the lower or high emissions scenario makes a big difference once we get out to 2100, right? There's almost no additional warming under the lower scenario. There's considerably more warming under the high scenario. So we have to reduce the greenhouse gas emissions so that we're on this scenario, but that's not really going to show up, right? We're gonna have to spend the money and do the investment now to get the outcome for our great-grandchildren. Good? Everybody understands? So I'm going to have a series of these graphs. So now I've brought it down. So now we've got Portland, Maine, right? Kind of the same story, right? No separation by the middle of the century. End of the century, there's a big separation. Portland, Maine was the closest city to Kennebunk that we downscaled to. We downscaled to places that have meteorological stations so we can constrain that information. What does that mean? What does that level of warming mean? So I've tried to provide a couple of examples. Let's look at days greater than 9 degrees Fahrenheit, which is how we define a heat wave. Right now in Kennebunk, most of New England, we have certainly less than 10 really hot days per year. If we look out under the high emission scenario by the end of the century, you can see that sort of coastal Maine down here is in the 30 to 40 range. Down in coastal New Hampshire, we're getting into the 60 to 70 range. But let's say 45 days per year at 9 degrees Fahrenheit. That's half the summer that's a heat wave, punctuated by slightly less uncomfortable days. Under lower emission scenario, we have far fewer hot days. We also looked specifically at wintertime temperatures. Our winters have been warming faster than any other season, in no small part because of the dynamics associated with our loss in snow cover and how that changes the reflectivity of the surface. So minimum temperatures under the high emission scenario, end of the century, we see that, right? Northern New England is 6 to 7 to 8 to 9 degrees centigrade. So call it, right, 15 degrees Fahrenheit warmer. We have winters currently like they have in South Carolina. So if you like to golf, we're going to have a lot more golf courses. Under the lower emission scenario, it's still going to be warmer, but we're looking more at the 3 to 4 to 5 Celsius. So 6 to 9, 6 to 10 degrees Fahrenheit. Significant differences. In this scenario, I think we keep sort of winter snow and ice-based recreation. Under this scenario, we completely lose that. Interestingly, for precipitation, sort of it's an opposite story from temperature, is we don't see any big difference between the low emissions and the high emissions scenario. So what's going to happen is that we're going to continue to see this increase in precipitation, but we're going to get more big events. And the big events are likely going to get bigger, and the reason is because a warm atmosphere can hold more moisture. All right, so again, this is going to be our most precious resource, and we're going to have more of it, but it's going to come more infrequently in really big events. So how do we think about storing that fresh water? It's a really big challenge. This is a similar kind of graph. We're looking at March, April, May precipitation. My apologies, this is still in millimeters, but for those of you that are good on your feet with math, 1 inch is about 25 millimeters. What I want to show you is that under the high emission scenario, you see this significant increase. So this is the change. This is the increase in precipitation under that scenario. So we're looking at something on the order of 4 to 5 to 6 inches more in March, April, May. And when do we have most of our flooding from fresh water? March, April, May. It's springtime storms. It's when the ground is saturated from snowmelt. Maybe that's a tough one. Maybe we'll still have a little bit of snowmelt, but the ground's saturated. The trees aren't growing yet. There's nothing to absorb that water. So when we get big precipitation events, this is when we get our really big flooding. And our models are consistent in saying we think we're going to have more springtime rain in the future. All right, so I just want to finish up my comments talking about a recent report that I helped finish with a group of really good colleagues in New Hampshire. And what I want you to do is, for this next phase, is not think about New Hampshire as a competitor. I want you to think about New Hampshire as your friend. And the reason is because we haven't done this report for coastal Maine in a long time. So we've just finished this, and coastal New Hampshire is not that far from here. In fact, we use the Portland tidal gauge as well as a tidal gauge at the Portsmouth Naval Shipyard. So the results are entirely consistent for this region. And I think we've done some pretty innovative things here. So I'd like to encourage you to, as you move forward, to use this report. Tom as well is familiar with this report as well because he was part of the review team. Weren't you? Yes. And again, at the end, I have a link to all these different reports. So this just gives you a sense of the number of different people that were involved in writing this. It's not sort of the world according to Cameron Wake. There was a whole group of scientists, primarily from the University of New Hampshire. We had some superb external reviewers who are experts in coastal flood risk. And we had a really big steering committee, and then we had technical advisors and adaptation practitioners. So this report has been read by a lot of people. It's been reviewed by a lot of people. And I would argue it's very, very grounded. One of the things we did is, as we looked at coastal flood risk, is we went beyond sea level rise. So we have a chapter on sea level rise. We have a chapter on changing nature of coastal storms, a chapter on groundwater rise, which you're going to hear much more about when Dr. Jane Knott comes and talks to you sometime in April or May. June. So groundwater rise is a huge challenge. As sea level goes up, it's pushing up the groundwater from below that can lead to flooding much farther inland than you would expect just from flooding from waves on the surface. We have a chapter on precipitation and a chapter on freshwater flooding. And we broke this down into a whole suite of key messages. I'm just going to focus on, I can't talk about the whole report. I don't have the time. I don't think you probably have the patience. But it's available for you to read. But I'm going to talk about sea level rise and about precipitation. So the most important point I can make about sea level rise, amid all the uncertainty about how fast it might rise, is that sea level is going up for centuries, and it's going to go up by many, many feet, dozens of feet over that time period. There are some glaciologists that suggest we've already passed the tipping point where most of Greenland is going to melt and West Antarctica is going to melt, which is about 40 feet of sea level rise. It's not going to happen next year. It's not going to happen this century. But sea levels are going up for centuries. And how you think about what your town does in the future, well beyond your lifetimes, I would argue really needs to absorb that piece of information. The way that the coast looks today is not the way that the coast is going to look 100 years from now, and certainly not the way it's going to look 200 years from now. There is no uncertainty in that statement. All the uncertainty is about how much by when, and I wish we could give you a better answer. I'm going to show you my best estimate, but sea levels are going up for a long time. Anybody unclear on that message? And then the second big message was that it's really this mass loss from Greenland and Antarctica that are driving that change, and the biggest uncertainty is going to be Antarctica, and that, right, relative sea level rise is projected to rise for centuries. And then I'll get to precipitation on my last slide. You can just go right through this. All right. So why does sea level rise? And this might get a little technical, but this is really close to my heart, and I just wrote the report. So there's lots of reasons that sea level rise. I've mentioned two already, is that warmer water causes sea level to rise, and that the transfer of ice from big ice sheets and glaciers into the ocean drives sea level rise. There's also this weird response to having all this weight sitting on the crust from the big ice sheets that were here. As those ice sheets retreated, the crust actually bounced back up. And now in this complex reaction to that, the inland is still rising, but the coast is subsiding. What we're really lucky about is sort of from Portland to Portsmouth, it's pretty small. If you go down to Maryland, it's really big. If you go down to South Carolina, half of their relative sea level rise is coming from the fact the coast is sinking. So that alone, be glad you don't own property in South Carolina on the coast. So what we did as part of this report was, I didn't do it, but I got results from Bob Kopp at Rutgers University, who's a sort of global expert on this topic. And we looked at all the different causes of sea level rise under this scenario called COP 14, because Bob Kopp wrote the paper in 2014, and under this lower emission scenario. So optimistic scenario, right? The RCP 4.5, lower emissions. So the orange line represents thermal expansion. The red line here represents glaciers and ice caps. The blue line represents contributions from the Antarctic ice sheet. The purple line is dynamic sea level. So as we have changes in ocean circulation in the North Atlantic, we can expect changes in sea level. It all has to do with changes in the Gulf Stream and changes in the formation of North Atlantic deep water. So that's dynamic sea level change. Land water storage, as we build big dams or we release big dams, we change the amount of water in the ocean. The blue line is the Greenland ice sheet, and geo is that coastal subsidence. All right, so these are all the individual components. And in this model, under COP14, RCP 4.5, you still see by 2100 that thermal expansion is still the single largest. But if you add up glaciers and ice caps, which are non-Antarctica and Greenland, Antarctica and Greenland, those three are bigger than the thermal expansion. All right, lots of detail. Next slide. So we've taken this, I would say, rather conservative estimate of the RCP 4.5 and COP 2014, and we developed a probabilistic assessment of how sea level would rise in the future. Again, we didn't develop it, Bob Kopp developed this, but it was applied for the tidal gauge at Seavey Island. And so what you're seeing down here in the blue line represents the central estimate, 4 represents the central estimate, 3 to 5 represents what we would suggest is the most likely range for sea level rise, right, out from 2018 out to 2150. So the graph goes out to 2150. So we're putting a 67% probability on that based on the probability distribution function of all those different processes that I talked about in the previous slide. Make sense? But we're also saying, look, there's a 1 in 20 chance that it could be actually right outside of that central estimate. So by 2150, it could be up around 6 feet. We've got a 1 in 100, a 1 in 200, and a 1 in 1,000 chance. So let's just take it. We took the 1 in 1,000 chance. By 2100, we're suggesting that sea level could be as high as 9 feet. 1 in 1,000 chance. Very unlikely, but possible. And one of the things that the reason we did that is because in our guidance for what to do about sea level rise is we have indicated that the first thing you need to do is assess your appetite for risk, for flood risk. That's what you need to decide about on whatever piece of infrastructure that you have. Once you decide what your appetite for risk is, I can tell you how you should prepare for sea level rise. If you're going to build an oyster shack on the beach, maybe you have a really high tolerance for flood risk, so you can start preparing for our central estimate. So, right, 2100, you're looking at the range of 2 to 3 feet. If you're building, say, a new wastewater treatment plant that you are very sure you don't want to flood, you might want to start thinking about at least the 1 in 100 chance, but maybe you even think about the 1 in 1,000 chance, because you don't want to have to rebuild that again because it's such a huge capital expenditure. So we think that this approach actually provides communities with a really good way to force themselves to think about what their risk tolerance is and then apply the sea level curves that we've developed. I'll reiterate that this is for RCP 4.5. And so this is a conservative estimate, and so for me, these are lower estimates, but also something that we know that the science is changing, and we have to update this report every 5 years. So if we find that Greenland is disintegrating much more rapidly, we will be able to adjust these upwards, but I am quite sure we will not be adjusting any of these values downwards, which we thought was a very prudent way to approach the challenge in a pretty conservative state like New Hampshire. All right, so you've seen this graph already. I just want to show you if you use a different model that has a different set of assumptions about what happens in Antarctica, and if you're really interested, I can talk about the physics of this, but it has everything to do with the fact that Antarctica has these really big ice shelves that are really high. And as those ice shelves melt backwards, they get higher because the ground underneath the ice shelves is sloping backwards. It's a reverse slope, so as they melt, they get bigger. And ice faces that are 600 and 800 feet high are fundamentally unstable. And we don't have the physics to figure out how quickly they will disintegrate. It is a fundamental problem that we cannot solve. So there's different assumptions at how quickly those will disintegrate. So if you take these assumptions from this really famous paper now by Rob DeConto and Pollard in 2016, DP16, you can see that blue line, Antarctic ice sheet, is completely different, right? Down here, by 2150, it's contributing like less, about 1/3 of a foot. Under the DeConto and Pollard approach, again, this is still RCP 4.5. It's not even the really high scenario. They're suggesting that by 2150, Antarctica could have contributed 3 feet of sea level rise on its own. So we used this model. We didn't use this model. Next slide. So it's sort of a word of caution, and it comes back to this point that we're going to be updating this every 5 years. In our estimates, I know this is a really complex table, and you can, it's in the report, but I do want to go through it a little bit because we've got the year 2030, 2050. We don't break out the scenarios because there's not much difference in the low emissions, middle emissions, high emissions scenario. They're all pretty similar. So these are really robust estimates on how much sea level rise is going to go up. That's sort of like the temperature. We're very confident in these numbers that the central estimate, so by 2030 we go up another half foot. This is increase in sea level from 2000. So this is half a foot and then a foot by 2050. And there's your 67% probability range, right? 0.3 to 0.7 feet, 0.5 to 1.3 feet. When you get out to 2100, what emissions there are actually count. Can you just hit that? So that's that one. The next one, right, for the 67% probability, if we put more greenhouse gas in the atmosphere, sea level is going to go up more. And we've quantified those. And that's, again, for the likely range. If you look at the 1 to 100 chance, right, we're talking about by 2100, sea levels going up in the range of 5 feet under the lower emission scenario, 6.5 feet under the higher emission scenario. There's a 1 in 100 chance that could happen, right? It's not likely, but possible, and we prepare for a lot of 1 in 100 year events all the time. In fact, all of you, I am quite sure I can make this statement that all of you actually have insurance for something that's less than a 1 in 3,000 chance event, which is fire insurance on your home. So just want to put that into perspective, right? So what's the insurance that we have here? I'd say we don't have much right now. Hopefully I didn't completely confuse you. I wanted to introduce the concept. It is complicated, but I do want to come back to the point that where you start is what is your risk tolerance? And then I can tell you what you should prepare for.
But you're also not talking about a risk of an event. You're talking about a risk of a different way of life. You know, that's not a fire. That's a persistent.
Right. So you might think of it of what fires used to do to communities, like, right, the Great Fire in Portland. That, yeah. Although the other thing, I just heard this the other day from one of my colleagues. They said that's not just happening in Maine. Right? That's everywhere in the world that's going to be facing that. So good, fair point. Point taken. So that we also looked at extreme precipitation events for Portsmouth going out in the future. So here's annual winter, spring, summer, fall events. 2 inches in 24 hours, 4 inches in 48 hours. Out 2010 to 2030, I've taken the high emission scenario here, 8.5. We can see that the biggest change we see is right in these really big, used to be rare, but won't be so rare in the future. So we see an increase of 60% in those events. When we go out, this should say 2069 to 2100, we see an increase in about 120%. So more precipitation, and more of that precipitation coming in big precipitation events. All right, on to my last slide. I'm doing pretty good on time, right? So, hopefully through this comprehensive planning process, you're going to talk about different strategies, both to reduce your greenhouse gas emissions and to adapt. One point I want to leave you with, I want to be crystal clear on this. The most important adaptation strategy is to reduce your greenhouse gas emissions because it reduces how much climate change you have to adapt to. That's not just a Kennebunk thing, right? That's a global thing, but everybody needs to do it. It's not about waiting for the other guy to figure it out. All of us need to figure that out. So mitigation is the most important adaptation. Go ahead. And I would argue that actually on my optimistic days that climate change is the innovation opportunity of the 21st century because it requires so many of our systems of the way we think and the way we plan and the way we use energy to change. Next slide. So I am optimistic. I think we can address this, but we can't do it by doing one thing or two things. We have to do a lot of things. So I think about this now in terms of the spatial scales at which we have to act. I'm quite sure the country needs to act. And what I really want the federal government to do is not tell me how to deal with flooding in my backyard, but I really want them to put a price on carbon so that we can transition to a low carbon society really quickly. I also want them to figure out a way better way to run the National Flood Insurance Program so that we move many more buildings out of risk. That, we need sort of federal dollars to do that. It's really hard to do at a state level or a municipal level. Regionally, I think of the Greenhouse Gas Initiative. I think about security associated with our regional transportation system, the interstates and the trains and our planes. There's lots that states can do, and I just want to say it's such a joy to have Janet Mills as our governor now, who has put climate change and dealing with it front and center. And then there's what cities and towns can do. We have to work at all these in order to address this problem. It's no one thing, it's all of them. And then we also need all these institutions to work, right? You cannot look to government to solve this problem. It is way too big. They don't have enough money, and right now I just don't have a lot of faith in my federal government to do much of anything. They need to do some things, but we can't wait for them to act. We clearly need business to invest in this, and in many cases businesses are taking the lead on this. And we also really need to think about what we invest our money in, and I would encourage all of you to interrogate your investments. Where we invest our money, that's going to actually provide the resources to fund the revolution that we need to address this challenge. Nonprofits have a huge role to play, from universities to art to our churches, and then individuals and families need to act at all. So why don't I stop there, and I'd be happy to answer any questions that you have. Oh, I'm supposed to remind you for the television to come up to the microphone to ask the question.
And if you can't come up to the microphone, we'll bring it around to you.
Do you want us to bring the microphone to you?
Well, right here I can get it.
All right.
Thank you. Thank you for your presentation. I do have a few basic questions. So the atmosphere is 78% nitrogen, 21% oxygen, argon, 0.5% or a little more. CO2 is one of the trace gases, about 0.04%. The human contribution to that is 3.5 to 4%. How does 4% of 0.04% have any impact?
So great question. It was physics that we figured out well before the Second World War. It's because carbon dioxide it's trimolecular, right? It has 3 atoms, and it absorbs long-wave radiation, especially in the band of 15 microns. So the more carbon dioxide you put in the atmosphere, the more those molecules actually absorb long-wave radiation coming from the Earth. Nitrogen and oxygen are bimolecular. They don't absorb long-wave radiation. But I'd put back to you, how many parts per million arsenic does it take to kill you?
True.
Yeah, so hey, we're made of water, right?
Yep.
A little bit of arsenic, doesn't take much. So different molecules in the atmosphere behave differently. And then you'll notice all of the greenhouse gases are all 3 atoms or more, right? So methane, nitrous oxide, they're all bigger, and it's because of that atomic structure that they absorb the long-wave radiation, although they all absorb it in different energy bands. And water is a really important greenhouse gas, too.
I was reading recently a crazy book, and I wanted to test their theory. They were saying that volcanoes, particularly big ones, have caused huge climate change because of the cloud of sulfur that comes out. So they've been in touch with a group that literally builds a pipe for 18 miles, but it goes straight up. And if you're from Canada, you're familiar with what's going on in Alberta. they would get sulfur for virtually nothing and put this pipe up that would be ended with nozzles spraying essentially sulfur, I guess, in the troposphere. Stratosphere. And that would then congregate more in the polar region as opposed to the rest of the world. And perhaps by doing that, which scared me to death even thinking about, but by doing that, you would create essentially an umbrella that would cool the Earth. Is there any merit to that?
I will try to answer your question, but limit myself to the time available, so there's a few other questions. So there's a number of different efforts at geoengineering. And the two aspects of geoengineering are, one, how do we suck carbon dioxide out of the atmosphere? And two, how do we increase the reflective nature of the atmosphere? So the sulfur, so it's true that big volcanoes serve to cool the Earth because they emit a lot of sulfur dioxide, and it's hot and it rises up into the stratosphere, and then it gets spread around the world and concentrated in the poles. And sulfur dioxide is an aerosol that is about the same size as visible light, and so it reflects that visible light coming from the sun, or it reflects a bigger portion of it. And we know this is the case. There's been a lot of computer modeling on this, but Year Without a Summer in New England as a result of Tambora, 1816, so there's proof for it as well. So the piece on the geoengineering is interesting to me because we don't need it to solve the problem. And we can solve the problem without all of the risks associated with, just think about that, an 18-mile high pipe. I mean, how many bridges did you drive over today that need to be repaired? And then the question is, who funds it? The second thing is, it doesn't last up there that long, 2 to 3 to 4 years, so you can't stop once you start. So who gets to decide? The other thing is, you cool the Earth, but you cool it differently, so you continue to have changes in precipitation patterns, even though the Earth is cooling. So what happens when there's a drought somewhere, because we have way more sulfur dioxide or sulfate aerosols in the stratosphere? You can imagine the legal ramifications of this. On the other hand, there's this really easy thing we could do. We could just transition to a renewable energy and energy efficiency at prices that are lower than fossil fuels and solve the problem as well. So you can tell I'm not a big fan of that form of geoengineering. Conversely, I've been really intrigued by the new efforts at chemically taking carbon dioxide out of the atmosphere. So I've always been a big fan of, we really need to invest in regrowing our forests. And guess who has shown the world how not to do it by clearing all their forests and then by letting them all regrow? It's New England, right? So we've become a big carbon sink over the course of the last 100 years, even though now we're beginning to develop a little bit. We're starting to reduce that area. So we have to enhance, I would argue we have to enhance tree growth. We have to figure out regenerative agriculture so that the carbon absorbs more soils. And then there do appear to be ways that you chemically remove carbon dioxide from the atmosphere on a chemically reactive surface, and then you can actually take that carbon and make synthetic fuel with it. And so there's 2 of those, one in Squamish, Canada, and one in Switzerland. And the people that run it claim they can get it down to $100 a ton within the next 5 to 10 years. So that's very intriguing to me because you actually solve the problem by doing that. But that would require an investment for it to work globally, something on the state of creating an interstate system. So it's not a small challenge. But I would say let's leave the sulfur dioxide to the computer modelers and stay away from it. Yes, sir.
I'm going to have to take the job, get PE credits. You mentioned precipitation events. And it seems one of the greatest concerns I would have in the next 50 years anyway is related to storm surge. Is the strength of storms that might be associated with that precipitation, is that factored into your thinking at all?
So we wrote a chapter on this in our report. I can't say that I don't have a specific answer for you because it's a really hard question to address scientifically. What the best hurricane experts indicate with the research that they've done, and Carrie Emanuel from MIT is one of them, and it's in the the National Climate Assessment, is that we don't expect there will be more hurricanes, but we expect what hurricanes we have will be stronger because they get their energy from sea surface temperatures. And what we've seen with Maria and Irma and Harvey is that as these hurricanes get closer to the coast, they just get really strong, really fast because of all that really warm coastal energy. So the question is one of those really big hurricanes going to hit New England? So that's the thing we just don't know, right? So there's going to be more in the Atlantic. A percentage of those will be landfalling. Will any hit New England? If it's a bigger hurricane, there's going to be a bigger storm surge. So New York and New Jersey, right, got their wake-up call. We haven't got it yet. So if one of those storms hits, yes, storm surge will be bigger. I have no way of knowing, and I haven't seen anybody do the analysis that shows that we will get hit. It's right now a question we can't answer. The flip side is that what we do have to deal with every winter are nor'easters. And I used to say before 2 weeks ago that we also can't answer the question for nor'easters. But at the Gulf of Maine 2050, I saw a presentation that shows that wind speeds in the Gulf of Maine have increased by something on the order of 50% over the last several decades. And so for nor'easters, we might see that increase in storm surge. So right now, what our guidance is we're saying just so like in Portsmouth, New Hampshire, probably up here, the storm surge is like somewhere between 5 and 6 feet. That's something we should plan for, plus sea level rise. There's no certainty that we can provide upon whether that storm surge will be greater at this point in time. I really wish we could.
My question has to do with mitigation, and I really like the quote that you gave us about that in relationship to amelioration. One of the major features of mitigation will be electrification. Wind turbines, batteries, et cetera, which rely upon a fair number of considerable use of rare earth metals. And my concern as I've been reading about this is where are these rare earth metals now in terms of geography, and a great deal of them are in China and other countries, and some of them we have a fair amount of, others we have relatively little. So in terms of trying to plan for mitigation, our considerations, and this is outside the realm of weather and climate, but I think it's important to be clear about where are we going to deal with this, how are we going to get all these rare earth metals in order to spin the windmills.
So it's a question totally outside of my area of expertise, right? You're asking a climate scientist about rare earth metals, but that's okay. That's never stopped me before. I'd back up a bit and say that the holy grail to a truly renewable energy system is one where we store energy. So we have to figure out ways to store energy, and clearly batteries that use rare earth metals are going to be an important part of that. And you're right, China has a corner on the market, but anybody see that 60 Minutes last Sunday? Right, so there's all these nodules on the bottom of the Pacific Ocean in the equatorial Pacific, and guess who's not out there getting any of those rights? The United States. But China's in, Russia's in, Canada's in, but the U.S. is nowhere. So I think it's a really important question. I don't know the answer to the rare earth elements. What I will say, though, is that's not the only way to store energy. And the way that they do it in Europe now with all the wind turbines in Holland and Copenhagen and Sweden is they send the extra electricity to Norway, where they pump water back up into their dams. So they have a hydro system that is their really big battery. And, it turns out that we could do that here in New England, too, because we have those huge reservoirs up in Quebec, and you can like them or you can hate them, but you can think about them as a key component to a renewable energy system in New England, where we send the electricity backwards from our wind turbines in the Gulf of Maine or from everybody having solar panels. I think it's something we need to think more seriously about. And then the other piece is that doesn't all have to be big batteries, right? If we all drive electric cars, and those wind turbines in the Gulf of Maine that the University of Maine and Habib Dogger want to generate, all that can just be stored in on our cars overnight when the wind is strong, and then we drive them during the day so that we have actually mobile systems. Really good question, and it's one that we need to keep asking. Maybe we should think about getting along with China a little better.
I'll just stand here and speak loudly. In terms of the geology of
I'm interested in learning a little bit about the consideration of saltwater intrusion or infiltration and what that might mean. Increasingly, given tax situations and so forth, more and more people are compelled to drill wells. And while I feel that's a problem too, nevertheless, I was wondering about saltwater intrusion for an area along the coast.
So I think that's another really important question, and I hope you come back in June when Dr. Jane Knott is going to be here, and she'll talk a little bit about that. So as sea level rise, right, that wedge of salt water that actually comes in underneath the ground, in the groundwater, is going to be higher, and it's going to likely go further inland. And so you're absolutely right, that can affect your well. So if you have a deep well, you might actually have a deep well that transitions into salt water. I think it's a really important consideration, and you might not want people to be investing a lot of money in a place where that might happen in the future. And if you hire Jane to do that analysis, she'll be able to give you some rough estimates. The other piece, and it doesn't end there. So as you have that saltwater intrusion, it's actually going to lift the groundwater as well. So in areas inland that are close to the groundwater table, you can see that lifting. So we've now just described what I would say is the two most important reasons why people would not live in their home. Because their water is salty and because they can't get rid of their waste in their septic system. I think it's really, really an important issue. And I wasn't going to bring this up, but I'm going to try. Bear with me. I just read an article in the New York Times about a community in Virginia that just restricted the development of 50 acres of property. And one of the people down there who was part of the town discussion said, you know, what we really need to do is just not build in stupid places anymore. And those considerations of, are you going to have fresh water or do you have a septic system, for me would be important criteria for maybe we just want to leave that land fallow. I would suggest that that's likely going to evolve over time because our science isn't great, but it's something that would be really useful, I think, to include in the comprehensive plan now. You got it. You got the microphone.
I know, and I have to ask the question now. So given all this research, which is very powerful, how does one influence municipalities, states, our country, that we can make these changes even if India doesn't, China doesn't? Because that seems to be the response. Well, why should we do anything when their impact is going to negate whatever it is that we do? So how does one move in the right direction?
All right, so I have at least 3 responses to that. It's a great question. One is I started out talking that this was a moral issue. And so from a moral perspective, if you think this is a problem, you have to act. And that's often put in the frame of when your grandchild asks you, what did you do when you knew? You better have an answer. The second is because it's actually the most cost-effective thing to do. Even if China and India don't do what we would like them to do, right? Transitioning to energy efficiency and renewables is going to be less expensive than continuing on the fossil fuel pathway. Ultimately, it's going to take investment up front, and it's going to provide many more jobs because that energy is coming from locals, right? So it's, you look at all, like there's more, what is it? There's way more people working in solar alone today than there are in all the fossil fuel industries. Many more. Like twice or 3 times as much. I'll have to get the statistic. So it's not just like a statement from a guy who's a climatologist. There's really strong data behind that. And then third is, I think it's really important to understand that China and India and Vietnam and Malaysia and Brazil understand this risk just like we do. And they feel that there's a moral imperative for the developed world to act because the accumulation of greenhouse gases, which last hundreds of years in the atmosphere, are from us. It's not from them. They haven't had their share of the polluting pie. It's their moral argument, and it has some basis. So they're not going to act until we act. So we have to act if we want them to act. And frankly, I would argue that China could turn on a dime so much more quickly than the United States, because with a totalitarian system, they can say, you will do it this way. But I think the developed world has to take responsibility for the greenhouse gases we own and act first. And in many ways, we are. We just need to do better.
Even if we pulled out of the Paris Agreement.
Yeah, we're gonna go back into the Paris Agreement. That's a short-term thing. Yeah, it's 4 years or 8 years. Sorry, I didn't say that. 1 year or 5 years. Yeah. It's 1 year.
I got here late, but I wondered if you had addressed at all or have any opinion on the power line corridor of energy that they want to put in bisecting our state, and if you have any input on that in terms of all of the climate stuff.
So I do have a pretty strong opinion on this, and you might not like it, but that's okay. Be happy to argue with you about it. Is that we need renewables now, and we need renewables 10 years from now, and we need renewables 20 years from now and 30 years from now. And so right now, I don't see any other alternatives for getting renewables into the New England market really quickly. That's something other than Quebec Hydro. So how do we get that power here with the least impact on our ecosystems? So they tried to do it through New Hampshire. It was a big problem. It was a big debacle. There were lots of problems. They were trying to put that power through the White Mountain National Forest, and I didn't agree with it. But I've looked at it. The Conservation Law Foundation and several other organizations have actually extracted a whole bunch of money out of CMP if they do it. One of the really important components of that is that the amount of energy that we can ship to Massachusetts is constrained by a bottleneck at the New Hampshire border. And part of the agreement is to make it so that as the Quebec Hydro fills that up, they'll make it bigger so other renewable energy that's generated in Maine can get sent down to Massachusetts as well. And then last but not least, it's going over all existing lands that are owned by CMP. So no eminent domain, no taking of lands, and the forest they have to cut, despite the rhetoric that you've heard, is not pristine forest. It's not old growth forest. It's 20 to 40-year-old forest that we cut continuously for paper mills. So there's definitely environmental impacts, but I think we have to act now. And most important for me is that we need access to the reservoirs, because they're going to be our battery to transition to a fully renewable energy system. So I've heard plenty of environmental groups say there's going to be no more renewables in Maine because we have this hydropower, and I would argue the opposite is true. 20 years, that energy is going to flow this way. After that, we'll be able to start flowing it the other way, and that's going to be really important for our big battery, especially in light of the question about rare earth elements. So that's my reasoned response. I think we just have to bite the bullet and do it.
The second part of your question was your reasoning as to why, like now you hear people say that Maine really isn't going to benefit from this, but you're saying we will benefit down the road going forward.
Well, no, there's $285 million in the deal for Maine. And the second part is you got to stop thinking about Maine as some isolated grid. We are part of the New England pool. The reason it says it's going to Massachusetts is because they have a law that they need green electrons. That electricity is going to serve all of New England, right? We got to step off the, it's not being used in Maine. All right, I think I'm going to take that pause because I think I'm a little bit over time. And say thank you so much for your questions, and I really wish you all the best. I can tell you I'm also chair of the Kittery Climate Adaptation Committee, so I am not a passive observer in what you're doing. I'm going to be really interested to see what you come up with, so I really wish you all the best.
Thanks so much. So I get to follow that. We're just going to take this back down a little bit to the comprehensive plan before we say goodnight to you all tonight. And Tom and I have a few slides that we're going to kind of breeze over, but I wanted to pause on this slide just for a second to kind of illustrate a little bit more how we're going to connect what you heard tonight to your comprehensive plan. So we'll be looking at the impacts of climate change and what effects climate change will have on all sectors, and we'll be incorporating that into all chapters of the comprehensive plan. And one of the ways that we're going to do that is to use this great tool that was developed by the Greater Portland Council of Governments and review some of the recommendations and guidance that this document has specifically for integrating climate change and adaptation into your comprehensive plan. So this will be a good foundation for us to use to touch on all different aspects of climate change. And then we'll, of course, be tailoring it to Kennebunkport. So we'll have this presentation up online also, and if you want to take a look at that resource, the URL is at the bottom of the screen there. But it'll give you an idea of how we'll start looking at integrating climate change into your plan. We have a website that Tom has created. It's excellent. And I'd encourage you all to check out the website. There's a place where you can sign up for updates. You can learn about upcoming events. We'll be posting blogs periodically. We'll probably have a blog about this event that you can read about. There are a number of resources. There's some maps from the previous comprehensive plan update. We'll be adding new maps and draft chapters as they're available throughout the process. So if you want to learn about what's going on and stay in touch, check out the website. We also have a Facebook page. If you are Facebook users, the username is Kennebunkport Comprehensive Plan. So we'll be posting information about events periodically also on the Facebook page. If you use Instagram, we are also posting information on Instagram with the handle KPT-comp plan. So if you use Instagram, please follow us.
Is it dash or underscore?
Either one will work. Yep. And we really want to emphasize that public participation is very critical. It's mandated and it's very critical for the comprehensive plan update. So we're thrilled that you're all here tonight. Thank you so much for coming out. And please come to the Growth Planning Committee meetings. They're twice a month. The public is always welcome. Most meetings, I think, for the next year will have focus on the comprehensive plan. And there'll be a lot of opportunity to provide input at some of our other public outreach events over the next year, and also to review drafts. And we really need your ideas and input to create the vision and guide the direction of the plan. Next up, we're actually going to have a table in this room at the Christmas Prelude, which I've never been to, but I hear is quite an event. So we'll be here. We'll have some information about the plan. We'll have a sticky dot poll, which we'll be inviting everyone who passes by to participate in. And we'll be there to answer questions, and members of the Growth Planning Committee will also be there.
Plus, we'll be serving some really good five-alarm chili and dogs.
Right here, yeah. So that's all we have scheduled for tonight. But we welcome your questions and comments. We've got about 10 more minutes until 8 o'clock. If you have any questions about the process, if you want to ask Dr. Wake a couple more questions, I'm sure we can get him back up there. But the floor is open.
I'd like to ask him one question. Sure. Now, the way I understood it, you said that the Greenland continent would melt all its ice?
So there's glaciologists that think that we've passed that tipping point where all of the Greenland ice sheet disappears.
But you're going out 200 years when you were talking.
Probably more, yeah.
Now, the way I understood it, if all the ice melted there and all the fresh water went in, it would stop that convection of like the Gulf Stream, which would cause an ice age. Now, I'm not understanding this.
All right, so let's go through this a little bit. So there's this really important ocean circulation pattern that starts in the North Atlantic, and it's cold, salty water. And so that cold, salty water, sort of to the east of Greenland, sinks, and it's called North Atlantic deep water, and it flows down along sort of close to the bottom of the Atlantic Ocean, where it picks up Antarctic bottom water, and it flows all the way over to the Pacific, where it surfaces for some magical reasons and comes back. And the return flow is the Gulf Stream. So the reason we have a Gulf Stream is because that cold, salty water sinks, and the Gulf Stream flows north to fill it up. As you reduce the density of that water, either through increased precipitation or melting of Greenland, you decrease the amount of cold, dense water that sinks, and so you change the nature of the Gulf Stream. And technically, if you want to learn a lot more about this, it's called AMOC, Atlantic Meridional Overturning Circulation. So it's in the Atlantic, it's meridional because it's flowing this way, it's overturning, right? It's ocean circulation. And so there's already a pretty strong indication that the strength of that circulation has begun to change. So the question is, if we dump a bunch more water into the North Atlantic and we really dramatically change the Gulf Stream flowing north, then the North Atlantic cools. And we think we've seen this in the past. It's been a really important driver of rapid climate change events, which I didn't talk about at all. So the reason that it can't put us into a new ice age is because there's just too much greenhouse gas in the atmosphere now. So none of the climate models, even if you totally shut off the Gulf Stream, show us going back into an ice age because there's too much radiative forcing globally. So the North Atlantic could cool substantially, but globally it would not. The Earth's temperature would still be going up. And actually, if you look at, I didn't show one tonight, but if you look at a map of increasing temperatures on the entire globe, the only place that is cooling is a dot sort of around Iceland and to the north, where that part of the sea surface is cooling because not as much warm water is coming up. So we used to think it could flip us back into an ice age, but there's just too much radiative forcing from greenhouse gases to make it happen now. Somebody's got to have a question on the comprehensive plan process.
You can hear me now, right? To what extent and in what ways is recycling a part of the comprehensive plan?
Well, I would say that we are open to addressing all aspects of what goes on in Kennebunkport, and I would say recycling is one of those aspects, especially if we're talking about where you're transporting your recycled materials to, how the town is encouraging recycling and by doing so reducing waste. It's an important thing to consider from a transportation of resources perspective, and also from a perspective of, I would say, municipal budgeting. Do you want to add on that?
Yeah, no, I agree with all that, but I'm also aware there's a game changer in China recently, and there's a lot of people scratching their heads like, what do we do now? And I don't have an answer for you tonight, but there's a lot of people giving that a lot of thought, and we are going to have the nation's going to have to come up with a solution, not just Kennebunkport.
Yeah, I think I understand that, and I understand what's happening in the market, generally speaking.
Yeah.
But what I don't understand is why we would put so many cars on the road to take renewables or things that can be recycled to a place 5-6 miles away, and the CO2 alone is a factor, and that needs to be thought about. And moreover, what about the transitioning out of curbside pickup? What does that mean in terms of the amount of recycling materials that do, in fact, get taken to a place where they can be recycled? So this is not just a simple question of the markets of recycling itself or China or any other factor. I mean, those are important, but it's also a local issue that has global implications.
No, I agree, and we have several members of the committee here tonight, and I think we're definitely going to look into that. Very good points.
Another one over here.
As a member of the Shade Tree Committee, I'm very concerned about the urbanization, basically, of Kennebunkport. There are a lot of people wanting to move in. And as they move in, I see them clear land, cut down trees. Trees absorb water amazingly. They're enormous ecosystems individually by themselves, not even just talking about the insect populations, the bird populations, the bacterial populations, the microbes that live in them. But they provide shade, they mediate house temperatures if they're planted correctly around houses. You can reduce air conditioning costs, you can reduce heating costs. And yet we see people come in and they clear the trees from a plot and they want large lawns. Lawns don't do anything, basically, to help take up CO2, while trees do and give off oxygen. In your comprehensive plan, and this is a very difficult thing to manage, do you have any ideas about individual regulation, not just about the size of plots that you can put houses on, but also regulating the individuals that live on them to not clear trees, to plant trees, to not basically mow those lawns down to a half an inch where the soil becomes desiccated, and various other factors that go along with that.
Very good point. I guess one thing I want to clarify is the comprehensive plan is an advisory document. It's an important one. But many of the recommendations that the plan will produce will be for changes to your municipal ordinances. And so it could be an important step in the direction you described. We could make a recommendation that the town adopt an ordinance that addresses that problem.
I would just add to that the town does have some existing regulations for landscape standards, so there's an opportunity to look at where sort of the existing, the foundation for incorporating those types of regulations to require better management practices, that infrastructure sort of already exists. So there's an opportunity to look at landscaping standards and regulations. There's policy considerations for what homeowners can do, and you have a great point that that trees provide tremendous benefits for homeowners in terms of energy savings, temperature regulation, and removing CO2.
The town of Kennebunk is in the process of developing a large parcel of land, and I'm just curious as how the Growth Planning Committee is going to interface with that particular land development effort.
Sounds like a question for the committee.
Yeah, I'll pass it off to the committee. I would say that one part of the chapter is looking at regional issues. So something that's occurring nearby to Kennebunkport would definitely be an issue that we would touch on.
Yep. So I suspect what we'll see is that there'll be a document that comes out of the visioning session that's been going on for the village parcel, and that's going to be referenced and probably incorporated at least as a reference document.
And I would say the other thing is notices will go out about each chapter and what's going to be discussed with each chapter. So if it's a topic that interests you, show up.
I live in Arundel, just up the Senate Road, but I'm interested in these issues. But one thing I wonder if people have thought about is the fact that, in a way, Kennebunkport seems to have be on the cutting edge just in terms of the fact that they even decided to take on buying that big parcel of land. I heard once or saw maybe on 60 Minutes a piece about a town somewhere out in the Midwest that was seeing tremendous development all around them, and this was quite a long time ago, and preemptively set up not just conservation trusts, but actually some kind of a governing body that started buying up any kind of land that came on the market, to the point where they ended up pretty much being able to control every single thing that was allowed to come into that town in terms of development. And I wonder if towns maybe ought to start to be looking, as Kennebunkport did with this property, at being more proactive about maybe taking a more aggressive policy about buying up land that's developable. As you mentioned, down somewhere around Virginia that they'd done that?
They just limited the development opportunity.
And maybe that's a different approach to accomplish the same thing, but, maybe as you mentioned, that it's not, that all progress is not necessarily a good thing, maybe, in terms of all of these environmental factors. Just putting as many houses into a subdivision as you can possibly cram, most of them with lawns and most of them cutting down their trees, may not be the best, route to go for the future of our towns, seems to me.
Hey everyone. So with the amount of water that we're, gifted with here in Maine, and with that increasing, has there been any thought about how to incentivize or allow catching and storing that energy? Like, say, rainwater catchment off roofs, or municipal level cisterns, or anything like that. We have this amazing resource of water. We should think about using that.
So there's a couple ways. I know that, I don't know where Kennebunk gets its water, but down in Kittery and York, we have some pretty big, nice reservoirs. So a lot of that water is already going in, like the more rain, more reservoirs. So you could think about how you manage those reservoirs. That's one way. Durham we did a really interesting thing in Durham. We actually take water now during the spring flood period out of the Lamprey River in a different watershed. Excuse me, we have a permit from the Department of Environmental Services to do this, and we essentially put it into a big sand pit. It filters down through the sand pit, and it recharges our aquifer where we get water from. And it's a limited flow aquifer, so the water stays in it. So we do that in the spring, it stays there in the summer, and then when the students return in the fall in drought periods, we actually pull from that. We have other sources, but it's kind of our reservoir. And then, Maine, Sebago Lake is a huge water supply for a lot of communities, especially in and around Portland. And that's another sort of wonderful system. So we are blessed with a lot of lakes. We probably don't want to build a lot of bigger reservoirs, but you could think about a bunch of really small reservoirs where we store that. I mean, when we talk about land use, they're fundamentally linked. And so if that's something Kennebunkport's really interested, you might want to start talking to your neighboring communities and thinking about how you might enhance freshwater storage in the future.
Again, I'm going to say something that's probably going to be controversial, but I think it's worth people thinking about, and that is the fact that within our country, even here in Maine, for instance, I have Kennebunk Light and Power, which I feel blessed to have a small locally controlled, but I don't understand the thinking, other than the fact that we're a free enterprise system, how we can allow foreign companies like Nestle and that is buying up all of our groundwater wherever they can, wherever the communities aren't wise to them. And then our power grid is now controlled by, correct me if I'm wrong, but some company in Spain. CMP. And you know, you see this where all our natural resources seem to be owned by foreigners, which I think is just strategically insanity. And do you have anything to say about that relative to the issues that you're talking about? Well, I mean, I'd just like to see if there is any part of that that is affected by all these foreigners who owning our groundwater and owning our electric grids.
So I'm kind of a foreigner. I'm from Canada. I'm an immigrant, though. Yeah, careful. I would emphasize your point about the groundwater, in particular, because my sense is that communities are selling their rights to their groundwater for next to nothing, given the value in 99-year leases. And so I think we need to get a lot smarter in the state of Maine. On the CMP, I mean, it is, I mean, at what point are you going to say no foreign ownership? Like, it's a really big discussion. I would argue that the bigger discussion going on about who takes care of and manages our grid is that should that be private, or should we go back to it being publicly owned? There's big risks, right? So there's problems where we're seeing the big challenges out in California with sort of, if you believe what the governor says, right, decades of underinvestment from PG&E now leading to big problems. The flip side of it is, do you want the public to be responsible for all of those risks? It's a really big question, but I think what's perfectly clear is that we need to bring the electric grid and the public utility commissions that govern it into the 21st century. It's a very different entity now. We don't have single big power plants and wires that go from them. It's going to be very different, and we have to be a lot more nimble if we're going to make a renewable system work. But I have no idea what the answer is.
We'll take one more question.
Yeah, not to mention our expertise.
The other aspects that were mentioned, you said that would be available to us?
Yes, our website.
Go back here to the website. There we go.
Our website?
Memorize that address up there.
Kennebunkportcp.info will take you to the website, and I think you can find it also through the town's website.
Yeah, if you go to the town's website, there's a tab right on the front page that'll take you to this site.
I'd like to thank you all for coming. And as Paul mentioned, there'll be a schedule of when we'll be talking about different chapters within the plan, and those that are, close to your heart, like all 18 of them. Please come and talk with us. We are trying to be very transparent. We want this to be our town's plan, and we need everyone to participate in that. Okay? So again, thank you very much. Thank you, Dr. Wake, for your great presentation. And Tom and Liz, thanks again for your work.